I'm online. So, I'm on internet. Ciao, mi chiamo Catalin Gheorghiu e vengo dalla Romania. Sono architetto di soluzione presso EPAM. Dall'anno 2011, ogni anno Microsoft mi ha assegnato il titolo di MVP. Le mie categorie sono IoT e Azure. Sono anche attuale MCT. Ho avuto idea di provare a fare queste presentazioni in italiano. E me provando mi è uscito soprattutto in rumeno. Ho bisogno di altro paio di eventi in Italia, 2 o 3 per poter farle in italiano. Per ragioni di sanità mentale continueremo in inglese. And so we got the important things that, yes, I'm from Romania. This means that we are good in bribery and stuff like this. So, and also lazy. So I'm going to bribe you to do this session. So we have chocolates. Look, I'm Babbo Natale. And also I need to bribe the photograph. Voglio avere migliore aspetto di Brad Pitt. Por favore. So this being said, what we're going to do this, in this session, we want to ambush Babbo Natale. You always waited for Babbo Natale to put the presents under the tree. Yes? Yes, you know it. So, let's see. Could you give me an example? What tactics have you used to get Babbo Natale besides waiting? Any example? A chocolate. Come on. Yeah, you say, well, yeah. What you have used? You can bribe somebody to wait for you. You look through the keyhole. You use a camera. Let's say we are in 21st century. You are always using cameras. So in this presentation, we try to see what we can do with the cameras to get that, let's say, Babbo Natale, which did not give us enough presents. So to cut him in the act. And we'll try to use, okay, we got this. We got the title, we got PAM systems, and now we're going to start our journey. Now I'll be absolutely politically incorrect, because we need to help remember our sponsors. So let us think about what technology you're going to think to use to process a vision. Again, for chocolates. Yeah, no ideas. We have chocolates. So, what are you going to use? Let's say an AI technology that it's new, like, come on people, ChatGPT, for example. Yeah. Okay. Or, who are you are working with Azure Cloud? Yeah, what technology I have there to do something with images? How it's called? Cognitive, yeah, I forgot my glasses. But, and this is a problem because I won't be able to hit you with this. Okay, here I'm trying to put on my paper to see how many minutes I have for each topic. This is why I... So yes, we'll have for sure ChatGPT, for sure Cognitive Services, and you lost. Everybody needs... If I do not have enough volume, I'll start... Mark will kick me out. My version of Sole Mio, it's absolutely not interesting. So, yes, these are the technology. So let's get rid of the... a bit and try to move, let's do a duplicate. And we have something like here. Let's start with this. This is somehow related with the real-world example, a pretty stupid real-world example that we use, but unfortunately I cannot share it. What is the scenario? We have a server room. And we cannot get more cables into that server room. It's a special server room controlling a power plant. And we wanted to see the temperature. So one of the ideas was to put a thermometer on the wall and using the surveillance cameras to get the values. Okay, here you have a similar example, trying with the ChatGPT vision, and also you see the Azure version of ChatGPT. It's public from a couple of days. You can ask access to it. You see what are the problems. I have a question for you. Again, I want to get rid of the chocolates. Just imagine I make the big mistake of coming here with my wife, and she's shopping, and I need to make place into the luggage. So, what will happen if the ChatGPT is not able to read the dials? ChatGPT, to simplify the question, it's always giving you an answer. Yeah, I see you that. Yeah, it's always giving you an answer. This means that it will hallucinate. If it's not able to get an answer of some sorts, will get you some answer. Another question is, what will get you as an answer? You see it in red. You get a nice line of text. ChatGPT is for interacting with us generally. So we will need something to parse the text or to try to get, or to create a better prompt to ask, is the temperature bigger or the speed bigger than 80 kilometers per hour? And I'll get rid of this because it's a bit hot. These are the issues with ChatGPT on using it. Other issue is, let's say, if you are working corporate, how are your bosses reacting to using ChatGPT or copilots? It's all happiness. Yes, you're working for, you're doing code for your customer, and you're allowed to use GitHub Copilot. Yes? Yes or no? Yes? I want to move to your company. Because in our case, I won't say in our case, because it's first confidential and second, let's not generalize. It happened that some customer will say, we do not want that code you create for us or our code should be using the large internet model. Yeah. So, okay, I'll give you chocolate. Because I'm trying to be Babbo Natale, I got the dimensions. I need to get the bird. Okay, so yeah, that's an issue also. If you are using this kind of large models, you need to have the data someplace public. Sometimes this is not nice. Let's see the other option. But first to the other option. Let's try to get something straight. We are talking about this. To see the terms that we are using in, let's say, in models, and we'll get in cognitive services. So we have classification. What is the difference here between this image is from a website which does not have, it has some relation with this, but they have a very good representation. Classification means that the model is telling you that someplace in the picture there is not what. Again, the difference with the Microsoft documentation is that a classification could be multi-object in the cases of, yes, you can look, they can tell you that I'm Peter, but not where. It gives you rounding box. In fact, rounding box, it's strange. La cerco della quadrato. Okay, it gives you the box. Detection, which is the most, let's say, common use in our scenarios. It's to put a rounding box and the label for each item. And segmentation, which is the rarest as usage, as far as I've seen. Maybe you have different experience. Is this one. It creates precise rounding boxes. So these are the terms that are used in this kind of models. A question for you, again, remember I have a lot of chocolates. I need to get rid of them. So these kind of models, they give you, for example, if I'm doing classification, I show you that picture. Is something like a ChatGPT prompt. In this picture, is Ellen DeGeneres yes or no? Or what it gives you. Let's give you a yes, a no, or definite answer, or something else. Louder. Okay, I give you chocolate because I see you. I hear somebody else, but it's no. It's give you a percentage. It's giving it's not a certainty. It's a percentage. I'm 80% sure or 20% sure that in that picture happened something. Okay, so these are the parameters. Let's go a bit further. We have a lot of websites. So, if you want to train this kind of models, what is the principle? You get your picture, you label them. So essentially you tell that in this picture we have this, this, and this. And then this part, depending on model, we can have classification. On classification, also I will show you. This is a small part of the demo. You can have these labels, or if you have detection, in this rounding box we have this. And then we train the model, and then we deploy the model someplace. On the large models, this job it's a bit obfuscated for you because the large models tends to get the data all over the internet and retrain and redone the stuff. It's a bit easier on us. But you see the difference. So let's try this. This is Cognitive Services from Azure. This is free up to 2 models. Anyhow, free means that you do not pay for this, but you pay for the resources. You can have, all of you, that you can have an Azure subscription for $200 or on month, whichever expires first. And in Italy, for sure, you do not need to show a credit card. You just put your details on email and you try for 1 month or $200 this. And $200 in this kind of models can take you quite a lot. So let's play a bit. We can try to be corporate. I've created for a conference a model that will recognize the EPAM sign. Or we can try to, let's try. No, I won't say the English word. I will say Gatti. Because the English word will be something started with P. And yeah. So, which one to pick? The corporate or cats? Cats, okay. Let's try we have here one classification and one it's detection. You see this is already trained pictures. And let's try to add a new picture. Let's try if you have any untagged. Yes, we have. So what it means tagging? Here there is a bug. I will explain, but later. Tagging means to get a rounding box around the cat, around the object, and put the label. We create before the labels. Here that could be the cat named Dooley, and this cat, it's named Dixie. Rounding box, and we say that this is Dooley. And after we finish this operation of labeling, we're doing the training. These are other tools, open source, that can do this. These from Microsoft are the best because they give you a lot of hints. Also, if they, when you upload a new image, they try to propose you. If you click suggested a picture, they will try to guess it. And sometimes this blocks all the stuff, but okay. So, this will be the operation. I will say, this is Dooley. We can say that this we have solved it. Let's also try to quick test the model. Let's get from someplace some cats. Let's try another. A cat trying to destroy the server. So, you see here it try to get the bounding box and also try to guess the probability. He said that is the other cat with the 98 probability. And I can tell you, the model is absolutely wrong in this case. But the solution will be to have more pictures. This have something like 40 pictures. It's a very small training base. And yeah, makes some sense, but yeah. You need, again, the difference to ChatGPT in which some of these iterations are done outside of your purview. Here you need to take care of what you put in and also to retrain it. In fact, we can look also at the performance of the model. And we have it, if we click here. So we have performance. So you see it's not great. It's 80 something. It could be better. And okay, the image count, you quote me, it's 51 for Dooley, 25 for Snežan. So there are two names of cats. Okay, this was detection. So we can play a bit also with also classification. That will be the other model. Here what we need to take care, you need to have also negative images. And this is why it's me, linear, and in the past. It's a negative image. I'm not a cat. So if we try to do a quick test, in fact, no, quick test won't be that relevant. Let's try to add a new image. Here it works. Let's say this one. I was expecting. Okay, this does not seem to work now, but generally you'll have. They will try to predict. They try to apply the model on the new picture to try to help you. We believe that this is this cat or this is this item. So you have a lot of bells of whistle to help somebody. And to tell you how accessible this is I work in the past with a model predicting the health of roses. Roses. Yeah. It's a plant. And we have the agronomic engineers, the pesante, using this tool, and they are doing the labeling and all the stuff. So they are taking the picture, putting the picture, click retrain the model, and we redeploy the model. It was hunky-dory. So it's pretty accessible. Okay, so now we have created the model. But the question is, well, we want to ambush Babbo Natale. So how do we get these to cameras? On ChatGPT, it's okay, we open a prompt to tell a connection of some sort of some kind. But if we started the connection of some sort of some kind, what protocol all the cameras use? Okay, I did not heard you, but you get the chocolate. So RTCPT, it's something like this. It's an old protocol. Unfortunately, the demo with this is very hard to be done. I will tell you also why, because here we are at Microsoft. If we are in production, it's no problem to open in the port and forward, open in the router and forward the port that the cameras are using. But all the cameras know to use, even your home cameras, or you can connect to the RTCPT stream. So they all can connect to that stream and get it to analyze. So that you can go to ChatGPT, or you can run someplace the model. My ideas of running the model, I have two, Microsoft. And, okay, the first one. So, Captain Kirk, it's yelling Khan. Any idea? I will throw it in that direction. I do not see who. Oh, yeah, I'm good. No, because he was unable to say this. This is the name of one technology from Microsoft. Okay, unfortunately, in this part of the world, the part of Edge, running stuff, Microsoft is not clear on what are the ideas. We have two ideas from them. I'm going to tell you all I know about them. Both are usable. I'm not sure that will be going too much into the future. What will be the issue with them? Maybe they will have another technology, but that will try to supplement them. On the bright side, both technology are open source. So you have on GitHub all the code, and you can do whatever you can do with it. I'm going to show you. The first one, and the one I prefer, and I'll tell you why, it's this CAN, Kube AI Application Nucleus. In fact, what are the both technologies? Is we are taking Kubernetes and running on edge devices. And then on that, we get the RTCPT stream, and we do processing. To understand another important stuff on the stuff with RTCPT, we need first to slice the image. They do not run on continuous imaging. You need to slice it. And there are services that do the slicing. Why do I prefer CAN? Because it's easier to set up. You can just say when you are doing the setup, I want to run it in Azure. Both stuff can run on Azure and also can run on hardware. In fact, on CAN, I will show you a bit of thread on where you can run it. And to finish this, the most interesting part is when you're running this on edge devices, which they have their own processor for doing inference. What's inference in your own words for a chocolate? Any ideas? Okay, I'm throwing an Andre. Andre, what's inference? Yeah. Inference is meaning running the model on the picture. So there are a couple of chips that are doing this very fast. And if you look at Calcio, you've seen sometimes there is a drone that follows. You see pictures of a footballer followed by a camera. So these are done by these kind of chips. Now the biggest player in this are NVIDIA. They are having much more interesting approaches. But the stuff with the drones, it's typically done with the Intel chips. But that's another story. So let us first show you technology and architectures, getting back to. So on both you have the repositories. And let's say this is the architecture of CAN. I'll say both are Kubernetes solutions. And you can run it whatever and whatever. This and also 5G automation, are open source. This means that they have bugs. And let us look when they were last updated. Because I had a discussion this morning, which one it's. So this is CAN, and it's July 19. And it was something like a document of something. The other technology, it's part of the accelerators that Microsoft thought about. And these are called 5G accelerators. This, again, an open source solution. And let's first see the bit. So, but this one internally, it's much more interesting. It's using DAP, PUB, SUB, MQTT. What I did not like at this, that this is a normal Kubernetes solution. So you have an issue of deploying easy to Azure. You do not have just a tick. I want to run it on Azure, and it will run to Azure. No, this you need to fight a bit. It's normal Kubernetes, whatever. And on this part of accelerators, there are other couple of two, but this one is the equivalent. Both do more or less the same thing. And let's look on the repository. Okay. Last commit was last week, but it was a document. So as you see, not much activity, but most probably it will be a next approach on this, again, will be with Kubernetes. This is the way through. And to be used in real solution, yes, you can. For sure, I'm pushing Babbo Natale. It's doable with both. But also for business solution. We have used it on real world, this stuff, and it works. Bear in mind that sometimes you have your share of problems. So let us, let's see, this one, it's what? Okay, this we know, but it's not from here. Let's get back to CAN, if we have it someplace. And let me look how much time I have. 10 minutes, okay. So it's just enough. I will show you how, what is the flow into CAN. This does not mean that, okay, I recommend it absolutely. I'll say it's simpler, some stuff, but it will help you to visualize all these parts and components. So first, you need to create a device. This is the type of device on which the model will be run. I said you can run it on Kubernetes something, or you can run it on IoT Edge. IoT Edge by Microsoft means to run some containers on your edge device. So this CAN knows about the management of that containers. You can see it from some place. I would say that let's try to create one. We create this because I hope that maybe the camera will work, but I'm not sure. Let's see. Test 3. So we can do it in the current cluster. And here you can see what we can use for acceleration. So I said, this type of device, because now we're defining more the type of device, can do the inference on the graphic board from it, the NVIDIA or an CPU. Didn't find my words. So we can pick, let's pick CPU for the sake of speed, and this is finished. Okay, and then we need to create a camera. The camera, we need to give her a name, and let's say camera. And here we need, let's put from some place a new URL. I will copy from the other cameras and hope that this should work, because this is a surveillance camera in some park in some place very far away. Let's see properties. This is the RTCPT, which I did tell you that you find it to everything and anything. All the cameras supported it. So let's give it a name. Test, it's good. And from this, we need to say which type of compute device support this. So we have put a real device, and this is the one that we have created, and a location. One of the first bugs that are around, you cannot create another location. The stuff with processing, it means that it cannot resolve the RTCPT, cannot connect to the camera. How I said, in real world, it's pretty simple. You go to the router and you forward the ports you need. Here, I believe that I will get kicked off the premises if I can try it. So for demos, it's not nice. And then let's play a bit. We need to create, see what models you use. Here, we already, in CAN, you see the models from the same subscription in the cognitive services. So you see the cut detection from the other side. Again, here a bug. If I create another model, you won't recognize my labels. So it means that each cluster can run only on one model. Okay, it's a limitation. Again, it's open source. If you like it, you can change it. And then let's create an AI skill. Babbo. So let's say here you have more options on what you can run it. So let's say here you, again, love NVIDIA Jetson. Yeah, 5 minutes, which are quite in time. So what we need to put after we run the model. This is for chocolate. That will be object detection. Okay, let's say yes. Better say no, because it's cheap. What we put after, let's remember, what it says the model. It give you yes or no, or what? Percentage. So, yeah. Andre, please, do you see who in the back? Yeah. So you need to put a filter. It would be smart to have a filter to filter the spurious because if you have a very low percentage, it's and here you put the percentage, and what else we can do? We can get out of here. So we can save what are the frames on which you see red-handed Santa. We can send insights to IoT Hub. This is, okay, the internal IoT Hub. It's not quite practical if you are not running on read hardware, or you can, okay, IoT Edge module, again, internal. This is the most interesting. You have an outside, you can have an outside HTTP endpoint, a function, Azure function to get the data. So let's see, and I have already opened, how this output it looks. Something like this. This is from PAM. So I have the bounding box, and yeah. And you see that usually a percentage is 80%. So you see that this wasn't run with this skill. You can tell me why? Because I have this percentage. Okay, it's 66. It's 66%. And to finish up this is the real deployment to hardware. We need to say we want to do this, and these are the compute device types and which camera they use. Okay, this one has no camera, so this one. This camera, and we need to say that we want this I skill, and okay, we need to add it. We won't go forward because I did a mix-up in the... But nevertheless, after you finish this, this is deployed where it is. Either it's your hardware, either it's your cluster, and it works. Generally works. The biggest problem I said is RTCPT from my point of view. The rest is click, 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 click. And pretty much this was the session. Now it's the, okay, let's get back to the what's important. We know this. Yes, and remember, who gave you chocolates? So let's do it this way. And also, if you have any questions. So my point is that these kind of technologies are ripe to use, and scenarios are limited only by your imaginations. Are pretty easy to use. So let's have more competition on this field. Not us be the only one who read thermometers from server rooms using these kind of technologies, or ambushing Babbo Natale. Remember, I want 20% from all your presents, if you can. Grazie mille.